Hello everyone. This is Prasad Tingle from Team Valid8rs. Today I'm going to give you a brief demonstration about our project Validate. So let's get to it. Okay. So the theme of our project is misinformation detection on social network. For this, we can see that the input for this theme is going to be our misinformation, and we have to analyze this information and provide a result whether this information is correct or not. For taking this input from the user, we have created two main things. The first is the UI, which you can see, and the second thing is an extension. So using this UI, user can provide us two main things. The first thing is a fact, and the second thing is a tweet. So let's go. Let's try to understand how the fact checking is working, and after that we will move on towards tweet and then extension. So let's say like user enters some sort of fact like India is a country. Now after he clicks on the check text button, it sends out a post request to our server. Now the server collects the related information on the internet using Google, DuckDuckGo, and Wikipedia. You can see the logs over here. As you can see, it is scraping the internet to for information and getting the unique information. And after it has collected all the sources from the internet, it structures it using the grok and then provides it to the LLM. For this project, we are using Mistral model, and using the LLM, it basically tries to analyze it on two broader parameters, which are source analysis and claim analysis. For the it can be subclassed into some other parameters as well. You can check all those parameters in our PPT. But after analyzing this, it creates a HTTP long polling session and provides the result on our front end. So here, as you can see, this is the result of our of the analysis. Now let's move on towards the tweet. Here user can provide a tweet ID for a particular tweet. So let's say like we go on our on Twitter or X, and we want to like check if this tweet is correct or not, and check this tweet for misinformation. So what we can do is we can simply like go on this tweet, copy this tweet ID from here. Okay. After the user has entered the tweet ID over here, he can click on this check tweet button, and similarly, it sends out a post request to our server. But this request is sent out to a different route, and there's some sort of change in the JSON as well. So here it's in a similar way. It collects the information regarding the tweet, but before that, the server has to extract the tweet data through the Twitter bearer token. Twitter, which you have to which allows the user, this server to interact with the Twitter, and after that it collects the relevant sources, analyze them in some sort of way, and provides the result using the HTTP long polling session again. So it basically like provides a verdict, the confidence level, explanation, the supporting evidence, the evidence analysis as well. This evidence analysis is based on some strength analysis of the evidence, the consensus, and the temporal analysis as well. So after analyzing those things, the LLM provides a verdict, and this verdict is provided over here. There are a lot more things which are getting provided, but right now we are just like showing these things in the front end. Also, we have abstracted this entire fact checking mechanism into an extension, like I said before. So let's say like the user is browsing through the internet, like on any website. Yeah. So if we are on this website and we want to check if this information here is correct or not, so what we can do is simply just select this text in this manner and right click on it. After that, we will be able to see the user will actually be able to see this menu, check for misinformation. As soon as it clicks on this, he clicks on the check for misinformation menu, this pop-up will appear, and on this pop-up the similar kind of result will be presented. The workflow is in a similar manner, just we are using an extension which provides the user a versatile way of interacting with our server and using this tool. In the meantime, it is analyzing. Let's try to deep dive in the architecture. I'll just give you a brief explanation about it. So this is the entire architecture. As you can see, there are two main things for the user to interact with our server. This is the first thing is the extension, and the second thing is the user interface. As soon as the user provides the input, which is going to be a tweet ID and fact, so it is sent out to this server one. Now this server one assigns a process ID to this particular request, and assigns a type value, and the tweet, if it, whether it is a type 1 request, then there would be a tweet ID as well. So this JSON is pushed into a message queue. After that, when as soon as the server 2 is available, it pops this JSON from the message queue, fetches the information from the Twitter, and collects the relevant sources regarding the information. And after that, it structures it using Grok and provides it to LLM. We are using the Steel model over here for analyzing. The result of this analysis is then provided to our front end using HTTP long polling session. Similar thing happens over here. This extension, the selected text is extracted over the service worker. The service worker hits the server, and for the extension, it only classify as a fact checking method. So that this request is always going to be type 2 request. Now, there are some reasons behind like having this asynchronous separation between these two servers, because that this server too is a heavy server. In terms of processing, it requires some time, and there's going to be some sort of latency between the server one and server two. So we need some like clear separation between the server one and server two. For this, we are using a message queue for communication. And similarly, this also helps in scaling as well. Like for instance, if we can have a replication of the server again over here, like we can replicate it similar in the similar manner for here, and the server too can take a different process ID, process it, and create a HTTP long polling session with that particular user interface. So the latency in the system can be reduced in this sort of way. But right now we are just like using the server too for processing. So this was the entire architecture of our system. Now I think we should go on towards the extension output. It should have been analyzed by now. So as you can see, this is how the output is going to be like arranged on this extension pop-up, and the user would be like able to select any text from the internet and send it towards a server for analysis, and the result will be provided in this pop-up. Okay, so that's it from my side. This is Team Validators. Thank you.